I was able to obtain a tactical dosimeter, which displays the current dose readings, or more like the total received dose readings, right on the fly, basically in real time. So this will be an extended version of my initial video about radiation protection gloves and an X-ray beam. First off, we start with rather normal X-ray doses in the primary beam. This was 90 kilovolts at 10 milliampere seconds.
25 Mikrosievert.
And as you can see, the patient would have received a total of 23 microsieverts here. Next will be the lead gloves. Same position and settings for the dosimeter again. This time it will be protected with lead gloves.
Von 25 auf 36 Mikrosievert.
From 25 to 36 microsieverts, so we had a total dose of 11 microsieverts during this exposure. Now the stupid dosimeter seems to feel slightly alarmed, but still it gets put into the bismuth glove and put under the direct X-ray beam again. (36 to 56 microsieverts), so the dosimeter just received a dose of 20 microsieverts. And now for a realistic stray radiation simulation on a human torso dummy.
56 Mikrosieverts.
And I just decided that talking English would actually make more sense during the recording. We're now using 109 kilovolts and 40 milliampere seconds.
73 Mikrosieverts.
So the dosimeter just received 17 microsieverts. Now with the bismuth glove in place, same settings again. Just making sure it's not in a direct beam here. And now it received 9 microsieverts, and last but not least, the lead gloves. And now it just received 2 microsieverts. So yeah, to sum it up, do not put your hands into the primary X-ray beam unless you're the patient that needs to be examined. And if you need to put your hands in the primary beam after all, well, then don't bother to wear bismuth gloves because they're pretty much useless. Only lead is capable of protecting you somewhat. However, if you're only exposed to stray radiation during radiological interventions, wearing bismuth gloves is pretty reasonable because they decrease your dose to about half of what you would otherwise receive on your hands. So yeah, but lead is still superior to anything given the high thickness of it as well. Those lead-free bismuth gloves are made for like surgeons, for example, so you can still do stuff while with those big lead gloves you obviously can't really use your hands for any fine motor stuff anymore. So yeah. Well, but enough about the medical experiments, let's have some true fun with X-rays. 125 kilovolts, 80 milliampere for 5 seconds. Boom, there we go. Just about 8 millisievert. Jeez. Seriously? Let's do that again. The alarm will go off at 15 millisieverts. Yay, alarm! Get the hell out of here! Well, I wasn't even in there, so no problem, but... well, that speaks for itself. Just setting it to the next alarm level of 100 millisieverts. But I'm not gonna do that because the tube would overheat. But yeah, at these settings, and we're at 105 centimeters away from the tube focus, by the way, from the X-ray beam focus. So that means at approximately 1 meter distance, you would get a dose of 5 sieverts per hour. So in theory, 30 minutes in one go would make you dead sick with radiation sickness. Of course, don't worry, nobody is ever gonna X-ray you for that long, and the tube would be on fire, or, well, it would shut off before that could happen anyway. But, well, it tells you that you really shouldn't, I don't know, mess around with X-rays too much unless you got a safe room that has lead glass and everything, like I have here. So much for that. I hope you enjoyed this little video.